Good evening, all. I hope all the participants have joined. So again, on the fourth day of basic FDP, that is Smart AI, Smart Health AI solution for modern healthcare system. Again, I welcome you all. On behalf of Vidush Institute of Technology and Research, Kadi, on the fourth day, our first expert is Mr. Nikunj Patel. He has completed his BE in Science in Specialization in Computing at University of Teesside, UK in 2012. He is currently associated as a senior engineer level 2 with E-Infochips Aero Company, Ahmedabad. He is having a total 13 years of experience in the industry, different areas or domain he has worked in job or independently, that are the water level analytics and its mineral analytics using AI, big data processing and analysis using AI, QA in automotive devices specializing in safety standards, QA in home security devices along with the server and database development and C#. So I welcome Mr. Nikunj Patel to start the session. Sir.
Yeah, thanks a lot.
Thank you. Okay.
Yeah. Please let me know if my screen is visible to everyone.
Yes, sir.
Okay, sure. So yeah, so as today we'll be having this session which is about healthcare data management. So when it comes to the AI solution for like any of the domain, including healthcare system, basically we need to have a core competency in terms of standards to be followed, privacy to be maintained, and data pre-processing, which would be ideally used for various solutions. So today we'll be covering up these three topics. Okay. So for today's session, we'll be mostly covering up below aspects like what is healthcare data, what is management, and how management can be done effectively. Apart from that, what all medical standards that are followed in terms of data management for healthcare, how privacy matters in management, and how processing helps data management. So basically, if we talk about data management, usually any of the data management, not only just healthcare one, but any other data management, it requires a strict standardization wherein all the participants or all the stakeholders must be following up a particular process or standard. Apart from that, there should be a privacy regulations just to avoid any of the data breaches and make sure that data is stored in a way and it is protected in a way like there would be no data leakage or any of the privacy violation. Apart from that, if we talk about the data in a very large quantity, so it basically requires a pre-processing before being used or utilized in any of the AI solution. So we need to take care of how the data is being processed, and it is redundant procedure. We have to almost run it almost like every day, enabled in order to get all the data pre-processing completely well within the time. Then one of the major aspect comes is interoperability. So basically, when we say interoperability, it means let's say we have some data stored in a one hospital a server, and let's say for any of the unforeseen reason, a patient has to move somewhere else. So all the data which would be stored over here in a particular hospital, it should be operatable by others hospital as well. This is just one of the general example. We will brief through about it later on. And the most required aspect here is the patient safety, because like overall healthcare data management is trying to treat patient at the safest way possible using AI solutions. So basically, these color pillars are collectively address all the key challenges that any healthcare organization might have to face in handling sensitive and complex data. Okay, so we'll go through firstly from the standards. So basically, standards are centralized data standards are critical for consistent healthcare data collection, exchange, and storage. So standard has to be followed while collecting the data from the patient or hospital, and whenever it is exchanged to any other hospital or any other doctors, that is exchange. And the storage, it has to be stored securely in a way wherein the privacy and all other valid policies are playing a bigger role. So currently, if we talk about major healthcare data management standards, it includes basically HL7, that is abbreviation for a term called Health Level 7. Apart from that, there is FHIR. Basically, it's Fast Healthcare Interoperability Resources. It is basically dealing with the international standards for exchanging healthcare informations. It is again developed by HL7 only. Apart from that, there is IHEXDS. That is basically a integrating healthcare enterprise. Basically, it provides a documentation sharing platform across enterprises. The last one is USCDI. Basically, it stands for United States Core Data for Interoperability. Basically, it's not a single medical abbreviation, but it's a standardized list of health data elements and classes designed to improve the um, interoperability. So uh, process standard process. So basically, all these standards govern patients' records, medication data, imaging reports, administrative transactions, and basically overall improving the interoperability and matching accuracy. So standards must be communicated across an organization and enforced by the governance and integrated platform and technology choices. So if you think about any of the medical report, let's say just one X-ray, and briefing that basically radiologists provide after end of the X-ray procedure. Usually, whatever data that is seen on the actual X-ray film and whatever data that is given by the radiologist, basically he like take care of a formal report wherein they describe in their medical term like this is happening, this is there, and something like that. So in terms of that, so if you see the this kind of text data from different doctors or different institutions, they might be varying from one to another. Even let's say a writing pattern may be different, we can say that way. So here, what we are trying to achieve using standards is basically standards is like defining a list of procedure wherein every practitioner or institution has to follow up that list of points and try to prepare data in a way which has standardized format. So it would be easier to go easier to integrate on the platforms as well. Okay. So, apart from that standards, there is a privacy as well. Another a key aspect. So basically, healthcare organization must comply with the regulated data privacy frameworks to protect their patients. So basically, it's about the medical or personal data being held by the data management enterprise, and the various healthcare organization. So basically, there is a regulated data privacy. Uh, so it basically protects the patient's data. So here we have like few global regulations. First one is HIPEAA, that is in US. Basically, it stands for Health Insurance Portability and Accountability Act. This is one of the data privacy regulation in US. There is GDPR, that stands for General Data Protection Regulation, that is in Europe. In India, we have DPDP, that is basically Digital Personal Data Protection Act, which was introduced in 2023, I guess. And there is one last MHMDA. Basically, it is Washington State Government Privacy Regulation. That stands for My Health, My Data Act. So these are the different regulations followed, we can say, by either country or across the continent in terms of data privacy frameworks and regulations. So basically, these laws required to inform patients' consent. Apart from that, it should be like clear notification of data breaches if in case it happens, and the administrative or physical and technical safeguards to protect the data. So, coming back again to the data violation, whenever data violation happens, we know like thousands of or more than basically in millions data is leaked, and it would fall in anybody's hands. So whenever such data leakage or privacy violation happens, it can attract severe penalties as well, since all these governing bodies and regulatory authorities are taking care of such data. So talking about India, DPDP Act, it requires basically all healthcare entities to secure personal and health data, while sector specific rules, just like Clinical Establishments Act, NCM Act, or straighten privacy. Basically, it is helping up clinical establishment to take care of the personal and health data for the patients. Okay. Now another aspect is data pre-processing techniques. So basically, pre-processing healthcare data ensures its usability for analytics and machine learning. So basically, it's we can last procedure that we can say. Basically, we have firstly formalized the standards for the collecting the data. Then we have privacy, like it's about the storing the data. Now we have a large amount of data available with us, like for healthcare. So we need to have it pre-processed, and whenever we are pre-processing any of the data, we can use it like for analytics, and if you wanted to use a machine learning to train a model, something like that. So basically, key steps for data processing techniques includes handling missing values, basically imputation, outlining detection, basically clustering method, and balancing data sets, that is SMOTE, SMOTE. SMOTE is basically a simple minority oversampling technique that was processed and can generate new synthetic samples at a data level and create balance between minority and majority classes. Basically, defining a group of data having some similar values. Apart from that, there is a data cleaning, which is absolutely required, considering, let's say, we keep on processing the data in a large amount, it would continuously piling up every day. So after some time, let's say down the line, 5 years or 10 years, or in case of somebody's demise, we might have to perform data cleaning as well, something like that. And there is transformation and normalization. Data normalization plays a big role in terms of data in reducing data redundancy. Let's say by any of the pre-processing, let's say we have some redundant data which is coming up again and again across multiple data sets, so we can normalize that as well. So like for a pre-processing, automated frameworks using metadata and rule-based algorithms can reduce manual work and improve model efficiency. Let's say we have a data of 10,000 patients at the moment, and basically if you consider at least average out like 5 years health data for each patient, it would be a really big chunk of data or file, we can say. So using that automated frameworks, by like using metadata or any of the algorithms, we can reduce the manual work. So like considering we are trying to process like 10,000 patients data using a manual work, wherein we have to go through each and every page and scan the data, put it in a way wherein it would be used in a um, analytics and all that. So if we go with the automated framework, it would ease up the task and improve the model efficiency as well. Basically, it reduces the chances of error or data redundancy. Lastly, for medical images, pre-processing commonly involves resizing, normalization, and augmentation. Basically, if we take an example of X-ray or a CT scan, something like that. So the document that would be provided as a medical test report, it would coming in all different sizes, and it basically requires a normalization. And as I mentioned, like there would be a text from a radiologist as well about how like interpretation for the any of the medical image. So it again requires augmentation. Yeah. So this is the summary table like across all three core elements like data standards, privacy laws, and data pre-processing. Basically, healthcare data management is anchored by standards and legal compliances, and pre-processing each essential to ensure data reliability, patients protection, and effective utilization for analysis. Any questions so far? Hello, am
No,
I
sir.
audible? Yeah. All
You
right.
may
Yes, sir.
continue, sir.
Okay. Yeah. So if anyone has any question, do interrupt me anytime you feel you wanted to ask any question. Yeah. Don't wait till end of the PPT or something like that. Yeah. Okay. Yeah. Let's move on with the um, recommended core data standards to adopt for healthcare system. So in this PPT, we'll be covering up like the essential data standards that requires to be adopted by healthcare system. And that core data standards would be helpful in terms of interoperability, clinical accuracy, and data exchange across varied healthcare applications. So, as we talked earlier, like core healthcare data standards, first one is HL7, that is Health 7. It is widely used global framework for exchanging electronic health information and crucial for system integrations and interoperability. Basically, it is widely used in US and other countries as well. Apart from that, we have FHIR, that is Fast Healthcare Interoperability Resources. It's basically a modern API based standard for fast and scalable and flexible health data exchange. Supports real-time communication, and it has app development as well, which basically helps inter communication of a data a bit easier, and it supports real-time communication as well if anything required on demand in terms of data. There is one more DICOM, that is digital imaging and communication in medicine. This is widely used for storing and exchanging medical images, ensure compatibility across imaging devices and healthcare softwares. So, if we go by the example, there is one enterprise you might have heard named Warfun, which basically deals with the uh, um healthcare devices and softwares. So what does it do is, let's say that machine, or let's say even healthcare software that is deployed across multiple health institutions, and whenever there is any report being produced, it would store that data on a particular platform, wherein it would have basically it keeps on storing the data in a way of a history. So it can be used by used for exchanging like medical images and across like different health enterprises as well. And it provides a portal wherein all this data can be accessed at any given point of time. So it has the data which is available like 24 by 7, and it is accessible across multiple healthcare institutions. So it again helps like with the data sharing and interoperability. Another one we have is LIONC. Basically, it's called Logical Observation Identifiers Name and Codes. So basically, this standardizes the code for lab test or test measurements and clinical observation. Basically, it helps facilitating the correct interpretation and exchange of test results. As we talked earlier, every radiologist might have a different way of interpreting the medical images. So this basically a standard provides identifiers, names, and codes, which would help to standardize the data format and the clinical observations. And once we have that correct interpretation in a standardized format, it would be easier to utilize in case of exchange of test results. Let's say we have shared data across particular health institutes, so it would be easier for everyone to get that data interpreted, as they are identified by the names and the codes which are standardized by the medical authorities. Another we have SNOMED city. Basically, it's called systematized nomenclature of medicine clinical terms. Basically, it's a comprehensive terminology that stands for clinical concepts, language, enhancing operability and granularity of medical records. The last one we have CDA. Basically, it's clinical document architecture. It is XML based standard, again developed by HL7 for consistent exchange of patient document across healthcare systems. So all these data standards that are adopted by healthcare system basically helps to have a data interpreted in a standardized way, stored in a particular way, and even exchanged in a particular way, wherein it would have seamless exchange of any of the patient's data or any of the healthcare data. Yeah. So here is the summary of all these core data standards. HL7, it's basically serving the purpose for messaging and interoperability. Basically, it provides system integration. That's the key benefit for it. FHIR, that is API based and real-time data exchange. Basically, it provides scalability and modern applications are available to utilize that. We have DICOM, that is medical imaging data, and it basically shares the benefit like universal image compatibility. LIONC, uh, LOINC, basically it's lab test and coding, sharing accurate results by the names and medical codes. SNOMED CT, that is clinical terminology. It provides a rich clinical description. And last, that is CDA, that provides document structure and it shares standardized record sharing. So all in all, by implementing these standards, basically it's play a foundational role for like um, building an interoperable, high quality healthcare data system that supports patient safety, analytics, and it also compliance with the regulatory and medical authorities as well. Yeah. Any questions?
Sir.
Yeah.
No, sir.
Okay. Sure. Yeah. Let's move on to the next. Yeah. So currently HIPAA, basically HIPAA, and GDPR, basically those data standards are basically ensuring the best practices for patients' data. So this practice includes conduct a regular risk assessment, evaluating data flow, access, and vulnerability in technology and processes. So basically, when we have a large quantity of data being, stored and used across different organizations, basically it requires technology and processes as well, just to provide data protection. Basically, it's falling under the privacy. Second, that is implementing strict administrative, physical, and technical safeguards. So basically, when the data is stored, that data should be accessible in a very controlled environment. It should not be, available to everyone or any of the medical practitioner or or those who are not having that grade. Let's say a doctor or assistant doctor, something like that. Apart from that, there requires physical security of facilities. Let's say we have a data center wherein all this data is stored. Basically, it requires physical security as well. And then lastly comes a strong encryption in transit and at rest. So basically, even let's say we have a data center wherein everything is taken care, but at the end we need to have encryption as well, in specifically in transit, or even it keeping it in the data infrastructure. So even if there is any breach in privacy or somebody is able to access that data centers, uh, it would help us to keep our data safe in a way wherein even if data is in somebody's hand, nobody can use it directly. This is similar encryption to what we see these days in WhatsApp and everywhere else, like data, wherever data is being shared or stored in a encrypted format. Yeah.
ગમે તે તમે પ્રતિવાદી ગમે તે આપો કાગળમાં લખો
Anybody saying anything?
કે ઉપર બીજું સાંગળ ઉતરી આવતી હતા ફટફટ વાંચે
Participants, please unmute.
તેને દુઃખી નોંધ લઈ
Mute yourself. કોણ છે?
Okay. Yeah. So further continuing with uh, let's say we have a data stored with the all the compliance and all the basically safeguards including physical and technical administrations. Apart from that, we basically need to have designated privacy officer and the security officer to see like ongoing compliance and incident management. So even if we are taking care of all the core practices like in terms of regulations, apart from that we have somebody to look after it and keep on monitoring. Basically it requires of a privacy officer or security officer which would keep on ensuring that compliance are matched every time or every single day. And even if anything goes wrong and incident happens, so how it would be perceived, what all aftermath need to be calculated, and basically incident management in case anything goes wrong, what should be done. And it again has some of the procedures. Basically, it's again a standardized format in terms of um, privacy and security of the data. Apart from that, let's say if we are running up with all these practices, we must provide comprehensive training on privacy, data security, breach notification, and sanctioning policies for violation. Basically, whenever we are preparing any of the standardized methodology to be followed by everyone, it should be communicated and communicated across the medical staff by providing them training on how data security and privacy is the key factor over here. In case if data is lost or privacy is violated, so it would be considered as breach. It should be notified across all the stakeholders, and basically there should be defined policies for the data violation. And last point we have is like about maintaining transparent policies for patient across patients access to records, notify the breaches, and clear investigation procedures for non-compliance. So let's say it's not just the one end procedure like medical enterprise is taking care of all the data breaches and aftermath or privacy violation, but that should be communicated to patient as well. Basically, patient should have access to the records in case if data is lost or privacy is violated. They should be notified, and the clear investigation process are to be served for any of the non-compliance. Basically, it should be communicated both the ways. It should be shared to the patient as well as healthcare enterprises and the medical regulatories as well. Yeah. Any question to anyone? Okay. Yeah. Let's move on. Okay. So earlier we discussed like HIPAA, HIPAA. Now this is GDPR compliance. Basically, it's starting with the thorough data auditing and mapping how and why patients' data is collected, processed, and stored. So this compliance take care of the data audits, wherein it keeps tracking on the patient's data that is being collected, how it is processed, and how it is stored. So basically, it's we can say a governing body keep on data auditing like for patient's data. Basically, it obtains explicit consent from the patients and using clear accessible forms and opt-in procedures for all processing of personal and health information. So again, when it comes to medical, we require to have patients consent all the time, wherein patient would be made aware, like and patient should be briefed in a way wherein a patient would have a clear understanding of how these forms would be accessible, how they can opt in for the procedures wherein personal and healthcare data it would be processed or even stored. So basically, it requires a consent. Usually, it is signed by a form from patient before sharing the personal or health information in a way of data. Apart from that, it requires a data protection officer (DPO). Basically, that's the officer or authority who is responsible for any of the compliance being not matched or oversight, or any of the operation procedures are not meeting up the uh, standard for me any of the core standards. So let's say in case of data protection is breached, and or if even if it is not breach, it is just oversight. Let's say any of the data that has to be collected in a way with a certain procedure or processed in a certain way with some standardized format and stored. So either of these procedures are not being followed, or any of the um, procedure is followed but not in a proper manner, it would be basically monitored by the data protection officer, basically to have compliance all the time. Apart from that, document like all the processing activities, data flow being used, or even third party data transfer mechanism, like to maintain transparency and audit readiness. So basically, when such procedures are being taken, basically it has to be documented in a way wherein it is taking care of all the activities and the data flows that are being used while complying with the particular practices. And then um, audit readiness. Let's say if some medical authorities wants to handle that audit, take an audit, data should be ready and documents should be very properly maintained at any given point of time. So overall, all these practices ensures like robust vendor management program, wherein government and non-government health institutions would have the contracts, regular reviews of their data processors, and the cloud providers handling the patient's data. So when we talk about a patient's data being stored, it would be basically stored in a on premises server, basically a physical data center, as well as on the clouds. So data would be stored at different locations as well, in order to save up the data in case data is being basically, let's say one of the data center is somehow physically violated, or let's say just the power outage is happening. So when we say one of the data center is not present, not able to present the data at any given point of time, there should be a cloud server as well, which would provide the patient's data. And it basically it runs with the vendor management program, wherein apart from health institutions, other enterprises would be involved as well. specifically for providing cloud services and support. Um, for cloud, one of the example we have is like if you might have heard like Amazon Web Services. It's basically called AWS, which provides the data server and 24 by 7 support, and that basically data stays on a cloud. So here, apart from the health institution, uh, um, tech giants are also involved in terms of cloud services. Again, whenever data is stored even on the cloud, it requires encryption, anonymization, strict control access, and ongoing monitoring to guard the data. So basically, whenever data is stored even on the cloud, it again requires an encryption. It again requires strict control access. Like not everyone can have an access to that cloud access, and basically it requires ongoing monitoring as well, just to ensure that GDPR compliances are being practiced all the time. So these are the two major compliances which are considered as best practices for data compliances. Okay. So when it comes to common strategies like for both HIPAA and GDPR. So basically, they have defined a few points wherein strategies would be treated common. For example, encryption. So it basically uses the modern protocols, basically for encryption AES 256 or TLS 1.3. If you might have heard, TLS stands for Transcription Layer Certificate 1.3. That is certificate security certificate for the server, and AES 256 is the encryption standards. Basically, this type of encryptions would be utilized across HIPAA and GDPR in terms of storing of the data and data is being in transit. So basically, encryption helps data security, and this protocol makes sure like data is secured all the time, even if it is in transit state. Apart from that, there is access management. So deploy a role-based uh, permission and multi-factor authentication to restrict the data access. For example, let's say any medical practitioner wants to access the data for a patient, and let's say uh, the doctor would be using a role which would be considered as a practitioner role, or let's say a surgeon role, or even the radiologist role, wherein with that particular role only and the multi-factor authentication only, data would be accessible. Similarly, somebody who does not have such roles, or let's say role somebody's who is also healthcare professional, but having role like a registered nurse or a doctor intern, something like that. So at that level of a role, they should not have a permission to access the data. So basically, keeping multi-factor authentication and the role-based permission would help to restrict the data access and have a controlled data access to the ones who actually need it. There is one more, incident response planning. Again, in terms of let's say anything goes wrong or data is being leaked or privacy is being violated for a data, so that should be notified in a way wherein all the stakeholders including patient would have that notification, and all the procedures that comply with the statutory deadlines, and and there would be a test plan wherein all the incidents are being logged in a particular documentation. That documentation would be acting as a incident response planning. So anything goes wrong, what all procedures has to be taken care, what all notifications to be issued, what all plans to be taken care in terms of data breach. Apart from that, there is employee training wherein um, um, training ongoing training for security, consent and data handling to prevent human error and promote compliance first culture. So basically, all the healthcare experts or healthcare professionals should be provided with the training wherein they would be made aware about the compliances, what all security procedures, what all consents, and what all data handling tricks to be used in order to prevent any of the human error, or just to have work culture in a way wherein all the compliance are taken care by everyone. Basically, it's kind of a rule that everyone has to follow while dealing in terms of data or security or the consent. At the end, again, regular audits has to be followed up, wherein they would conduct frequent internal audits. They basically make an assessment for any of the vulnerability, and it updates regularity and the evolving risk. So basically, let's say we usually hear on news wherein data is being breached or data is leaked, let's say for thousands of users. So so basically, whenever this kind of data breach happens, there are few factors behind that wherein uh, some of the standard security procedures are not being taken care in terms of technical aspects. Let's say data servers, using old security certificates or old encryptions, or not even like having security patches installed or recent upgrades wherein security patches are applied to the system. So this kind of uh, uh, this kind of miss in terms of technical aspects might lead to uh, uh, incidents wherein data would be breached. So having these frequent internal audits would help to see, like keep on monitoring, like if everything is being updated. Internal audits take cares of the assessment wherein even if it is missed by someone else at the end of the day or at the end of the audit, it would be highlighted and taken care at the earliest. This way, it would help to have a data stored very securely and in a safe way. Yeah. Any question? Anyone have?
No, sir.
Okay.
Participant.
Sir, there is a one question.
Yeah. Hello.
Just a minute in chat box.
Okay.
Is any health database available in India? If so, what is its name and how can one obtain data for the epidemiological research or study?
Okay. Yeah. Um, in India, basically, we have health database available, but it is like not accessible across all the medical enterprises. So basically, I can share an example wherein, let's say we talk about the Red Cross Society, wherein they are storing up the basically they are acting as a blood bank. So there is a data uh, for all the blood donors which would be kept for all the like all the blood donors and those who already have um, donated. So basically, there is a database which is independently being maintained by them in terms of health. However, the data that we were talking about is like about the medical history. We don't have like such data available at the moment. If you uh, we currently like uh,
Sir, your voice is not coming. Please check your audio. I think you
hello.
are muted. Yes, now audible.
Yeah, audible. Yeah.
Yes.
Yeah. So, yeah, audible now, right?
Yes, sir.
Okay. Yeah. So, as I mentioned, like we have like health database available. That is basically varying from health institution to institution, but we don't have such common database which we talked about, like in US or like in Europe. Like we have like they have the that kind of data base available to their country. Even in UK, there is National Health Services, that is called NHS. Basically, it provides a unique identification number to the patient, wherein all the medical history and the data would be retrieved from that um, database, healthcare database. But over here, we don't have that unified data available, like dealing in the healthcare enterprises across all the healthcare enterprises. Yeah. Any other question? Okay. Yeah. So, practical pre-processing pipeline for messy clinical data sets. So basically, if we talk about the pre-processing the medical data, basically it requires a multi-step approach from initially cleaning the data, complete the validation, and have data in a way, feature engineering tailored that would be reliable for analytics and modeling. So basically, it requires a step-by-step approach in terms of practical pipeline for completing the data pre-processing. So first of all, that is data profiling, um, wherein data would be assessed, the data structure and the contents, identify the missing values, outliers, duplicate records, and inconsistent formats. As we talked earlier, like there is a high chance wherein formats would be differing from institution to institution. You might have a data redundant due to a duplicate records, or any of the structure or content of the medical data might have missing values as well. So it basically takes care of the data by profiling each data in a way wherein it would have all these aspects outlined. Basically, if data is being missed, data is being missed, like let's say some of the values are not being present, or data is being duplicated, or a format is not consistent, it would be profiling data in a way wherein they would, that way it would be easier to process the data. So firstly comes the data profiling. Basically it is like creating a set of a data with um, either structure in a data structure, or another set wherein it would have missing values, another set wherein it would have inconsistent formats, and one more set for the data duplicate records. So once we have that data profiling completed, then we require to have a data cleaning. So basically data cleaning requires removing and leading and trailing spaces in the text fields, correcting the numerical values, let's say 40 or actual number 4040, wherein numerical value should be present in particular column. Standardized formats for date, codes, and clinical variables. For dates, it is required considering not every institution would be following or the same data format like DD, MM, YY that we have over here. It varies from country to country as well. Medical codes basically which should be standardized across every health enterprise, and the clinical variables, basically all the naming conventions that are used across the healthcare clinics. Apart from that, we need to have a handle missing values, wherein basically it is about imputation, wherein median or mean would be missing, or basically let's say by an example, let's say we need to have a data wherein let's say if we talk about even let's say blood sugar data, wherein data would be having two different values. One would be FPS, that is fasting blood sugar, and another would be PPBS. So these two data, two values being defined in a way wherein if a median has to be taken out, it would be calculated in a way wherein a data would be acting as a median as well. So if we go for the report such as HbA1c, wherein a median would be calculated. So basically it is all about the handling the missing value in case if it doesn't have that way. And at last, duplication of the records or a double counting. So redundant data would keep on would keep on increasing the size of the data set, as well as it might end up having a double counting as well. So duplication of the records has to be done as part of data cleaning. So once we have this data being profiled in a different sets, and then the data being cleaned in a way wherein it has standardized format, corrected numerical values, removed the spaces, and duplicate records are being removed, then it goes for a outlier and the noise handling. Basically, it detects and treat outliers using Z-score and IQR methods. So basically, reducing the noising data. And when let's say we have let's say we are accessing medical history for let's say last 5 years. So in 5 years of a data, we would have outlining like for this particular year, this was the report which has played major role in the health or even in any operation or surgery. So basically, let's say we wanted to have a comprehensive data for a 5 years of medical history. It has to be in a summarized format wherein noisy data would be reduced and clustering approach would be taken care, wherein data is being formatted in a way wherein it would be easier and easier to read and have a comprehensive history for a medical record. Apart from that, categorical variable encoding. Basically, it provides transform categorical variables in one hot encoding, label encoding, and embedding. So basically, it basically deals with the encoding categories, wherein variables are transformed uh, in terms of labeling and embedding. Um, one more we have is like future transformation, wherein normalize or standardize the numerical columns to improve the model robustness and aggregate the data if needed for cohort, time series, and multi-source analysis. So as we talked earlier about like having a data provided in a way wherein column requires to have a numerical data, or let's say we need to have a numerical data in a way wherein we can train the model and have analytics being generated by that um, data transformation. So that has to be normalized and standardized first, and then it would help us to aggregate the data out of that entire medical reports. The last one is data consistency and validation. So after having like all these cross checks for consistency between source, column mining, and intended values, and validate the split between training and testing set for model readiness. So basically, once we have uh, model ready in terms of a data wherein data is being generated every time, um, so there should be a validation wherein data being trained and data being sorry, model is being trained by the test data and the actual data in terms of medical data sets, clinical data sets, so that model readiness can be achieved through that validation. Yeah. So this is the overall summary for the pre-processing data sets which we talked earlier. Um, it basically goes through the stages wherein it requires profiling, cleaning, outline, noise, encoding, and transformation. At the end, it requires validation. So, so this end-to-end pipeline can be implemented by implemented in Python using pandas and scikit-learn, and it offers basically automation and reproducibility for a large scale data. As we talked, if we wanted to process data for let's say 1,000 patients and having medical history for more than 10 years, it would basically done by the automation, and Python would be helpful in terms of developing a model wherein a data would be processed in a way it would help us to prepare um, w- um, uh, proper data and validation checks at the end. Okay. Yeah. So here are the few examples for data standards which we already have gone through. So HL7 is basically L level 7. Basically, it provides two version. One is V2X and the latest one is V3. It is basically a widely adopted messaging system. It helps like with the data exchange, and it enables the interoperability between healthcare systems. Uh, FHIR, Fast Healthcare Interoperability Resource. It's modern API-driven standard for fast and scalable healthcare data exchange and integration. Um, LOINC. It provides standard codes for lab test and clinical observations, ensuring consistent interpretation of results across all the systems. DICOM, that is standard for managing, storing, and transmitting medical data and specifically imaging data. CDA, that stands for clinical data, clinical document architecture, wherein it provides standardized format for the document for patients' record, enabling machine readable and human readable exchanges. So same thing goes for privacy examples, data privacy. As we talked earlier, that is HIPAA, but basically Health Insurance Portability Accountability Act. That is regulation followed by the followed in US for protecting patients' health information, defining privacy and security rules, including access controls and breach notifications, including patient rights. GDPR, that is General Data Protection Regulation, widely used in European Union. Basically, it imposes strict requirements for patients' content, data minimization, transparency, and cross-border data protection. One is High Tech Act. Basically, it's the act enhancing HIPAA regulation with the focus of electronic health records and breach reporting requirements. Um, One more is business associate agreements. Basically, it identifies the contracts, ensuring the third party vendors complying with the healthcare data privacy and security standards. As we talk, like data being stored at the cloud enterprises as well. For example, AWS. And last one is role based access control, RBAC. It basically gives secure measurements, ensuring like authorized personal access to the sensitive patient's data. Last one is data examples for data pre-processing. It requires data cleaning. It is basically applying imputation techniques and dropping inconsistent record to improve the data set qualities. Normalization and standardization transformation. It helps with the transforming variables such as lab tests into consistent scale to improve compatibility for analysis and modeling. Outlier detection identifies it treats anomalous clinical values via Z-score or IQR methods. Basically, it helps reducing the noises in the data. um, Categorical data encoding, basically it helps converting clinical categories like diagnostic codes, medication types into machine readable numerical formats using one hot or label encoding. Last one is data duplication. It helps removing the duplicate patients records, maintain integrity and avoid bias in analysis. Yeah, so these were the like overall example for standards, privacy, and pre-processing for healthcare data. So how these standards would improve the interoperability efforts? So basically, by following up all the data formats, data standards, and privacy policies and pre-processing um, um, points. So here like there are few efforts that would help improve the interoperability. First, it consistent data exchange. So whenever data is being exchanged, it should have a defined structure and formats wherein data can be read and processed accurately. Be it data is coming from the electronic health record or lab results or imaging data. Semantic understanding. So the terminology standards such as SNOMED CT and LOINC provide common names and medical codes, wherein every different system interprets data in the same way. By this, it can reduce the error and improve the safety. um, Next one is reduced integration complexity. So by adopting universally accepted standards, healthcare organizations avoid costly custom integrations and complex data mapping, wherein it helps like they can accelerate their deployment, basically lowering the error in data exchange workflows. um, um, then we have support across ecosystem. So basically, the standards that allow interoperability beyond individual providers, connecting patients, payers, public health entities, researchers with unified and secure access to comprehensive health information. So basically, it helps like creating an ecosystem wherein it would be easier for like every individual governing bodies or even the healthcare professional researchers to have data shared in a secure way, comprehensive way. Last one is level of interoperability. So it helps standardize and facilitate all the interoperability, like from foundational data transmission to structural formats, data consistency, organizational policy harmonize, critical for secure scalable data sharing. So these all the points that would help data standards to improve the interoperability efforts. So if we have this standards being followed, so it would help, how it would help, like it helps with the improving the patient safety. Basically, it provides a complete access and accurate patient history to avoid any of the medication errors or such events. It provides streamlined care coordination, so the data lowers administrative burdens and supports timely clinical decision across the care settings. It enhance public health surveillance. It shows up the real-time data exchange, avoid outbreak tracking and population health management. The last one is innovation and research. So this standardized data basically helps in analytics, preparing AI applications and evidence-based medicine. So like this, all the benefits that are being enabled by operability via standards. So now we are comparing doing comparison on how data health management works in US versus India. So basically it has some differences. So in US, healthcare data management is basically a regulated, standardized, wherein it has several uh, federal incentives, basically high tech programs and ARRA, which is helping certification and enforcing interoperable standards like HL7, HIPAA. Basically, it helps with the privacy and frameworks. There is insurance driven workflow as well, wherein in US, wherein they yeah, they accommodate insurance claims processing and detailed clinical documentation, including nursing care plans after medical procedures. Last one is technology stack. They are using the expensive license platforms like MS SQL and .NET and are prevalent, and data storage is mandated to be within the US as per the HIPAA compliances. So the data would not be accessible outside of the US. And the deployment, wherein they are having hospitals mandatorily using EHRs and schedule adjustments, enabling more controlled rollouts and training and support. So as an example, I can share one of the example here. You might have heard eClinical Works, that is a company based in Ahmedabad, dealing in the healthcare management systems that are currently widely used in US. So they are providing all these services in a way wherein healthcare system are having standardized format privacy regulations as per US government and standards. Okay, so in India, in India we have emerging ecosystem wherein national digital health ecosystem is being built, though it is not fully deployed, but they is building up, including national digital health blueprint, health ID systems, but lacks comprehensive personal data protection law, like specifically in health data, as we have like standards in US or Europe. Apart from that, in India, health data management is basically acting as a cost sensitive and high volume workflows, wherein in India it is designed for quick and problem focused documentation due to high patient volume and the shorter consultant times. And the open source platforms being used like PostgreSQLs, PHPs are favored in a way to reduce the cost for the data management structures. Privacy, though the principle of the privacy and security exists, but enforcement and legislatives backing are less matured as compared to other countries, but interoperability is still developing. The last one is deployment and adoption challenges. No financial incentives for EHR adoption. Clinicians often resist switch from paper records, basically it requiring strong change management and end user support during implementation. So there is a difference in terms of um, healthcare data management use being used in US and in India. Yeah. This is the overall summary which we just briefed about. We have the different aspects such as regulation and policy, wherein US we have HIPAA or high tech, or it provides basically data security, wherein in India we have digital health, um, national digital health blueprint NDHM and DISHA, that is in draft state as of now. So the primary EHR drivers are insurance claims, evidence based care. However, in India, we have high patient volume and problem focused care. Uh, um, then we have a platform and tech stacks. Basically, in United States, they are using licensed platforms and strict data residency. However, in India, we have cost-effective and open source platforms being used. Privacy and security. There is a strong enforcement in US. If anything goes wrong, there is a heavy penalties are as well. Where in India we have nascent and policies still being evolving. Um, EHR adoption, basically it is government initiatives and hospital mandates in US. However, in India we don't have such thing. And lastly, interoperability. Basically, there is HL7 or CCDA as a standards In US, we have a very limited cross system sharing as of now in India. Okay, so lastly, we have like, if even if we let's say achieve like all these data standards, policies and pre-processing of the data, how it would be, beneficial to the doctors firstly. So basically, it improves the patient care and the outcomes. Basically, it gives an access to the comprehensive, accurate patient's information. Basically, lab results, allergies, medical histories, and that unified system enables better diagnostic and personalized treatment and reduce medical errors. Similarly, real-time data would be, help them like monitoring and predictive analysis support, like proactive intervention, shifting care from reactive to preventive, and streamline the workflow and efficiency. So electronic health reports reduce basically a paperwork. It prepares automated data entries, appointment scheduling, billing, allowing doctors have more time for patient interactions. It enhances collaboration and communication shared across the care teams, and it basically enables multidisciplinary approaches and remote consultations. It also helps with the decision making, wherein the data management platform provides clinical decision support system and tools to access the larger database for the evidence based practice and the medical research. The last one is regulatory compliance support, wherein automated tracking and data security features facilitate adhere to privacy laws like HIPAA, reducing legal risk. So basically, these all the benefits, coming to the doctors while treating any of the patient, if they have the strong database management available, healthcare data management available. However, there are few drawbacks as well for the doctor. Coming up to the data overload and complexity. Basically, considering a massive amount of data can be overwhelming to the doctors and making them challenging to extract the relevant insights, and without using advanced tools or training. Basically, it would be considered as one of the drawback. Apart from that, learning curve and usability. So adoption of the IT systems often requires training, and poorly designed electronic health records. Basically, it can hinder the efficiency and cause the frustration. Interoperability gaps, incomplete data sharing can result in fragment of patients' data, increasing risk of duplicate test and missed medical history. Um, One more is administrative burden. So basically, it increase the documentation requirements and compliance related tasks add to doctors' workload and sometimes reducing direct patient care time. And last one is data privacy concerns. So despite like security measures, there may be a breach that remain concerned and may affect patients' trust and physicians' responsibility. So these were the benefits and drawbacks for the doctors in terms of healthcare data management. Same thing goes for um, patients as well. So if we have such our data management available, it would be benefiting patients in a way. It would have a better quality of care. Basically, it provides unified and accurate data, help doctors make precise diagnostic and tailored treatments, improving outcomes and reducing medical errors. It improves patient safety as well. Timely access to the medication records and allergy information reduces adverse drug reactions and harmful interactions. Enhance patients' engagement. Digital access to the medical records and health data empowers patients to be more informed and involved in their care decisions. Faster and more efficient care. A streamlined administrative process reduce wait times, redundant tests, providing quicker and smoother healthcare delivery. Personalized and preventive care. Data analytics can help like providing monitoring devices, enabling proactive interventions and personalized treatment plans, evolving health status. Continuity of care would be, have centralized health data that ensures like coordination across multiple providers, preventing duplicated services. The last one, health trend tracking. Aggregate data informs public health policies, help track emerging health threats, benefits to communities at the large. So here I can share one more example about the patient's safety.
Hello, sir.
Yes, yes,
Sir, there is a question.
yeah. Please go ahead.
Don't think-
Hello.
Just, sir, the question is, how do I verify that the medical data I have taken from the Kegel is correct?
So so if the data is correct or not, basically it depends on the if they have utilized standard procedures and the um, uh, while generating the data reports, and we might have to cross check that data with the physical records that we might have on hand. So again, even if let's say if health related data is leaked, so in even if data is leaked, it would be just considered as the violation to the data personalized data protection. Uh, Basically, it gives you know uh, it gives uh, when the data is health related data is leaked technically. So here there are a couple of points that we might need to take care, like if the data that is being stored was it with the consent or not. Second, if it was with the consent, was it encrypted before storing up or not. So even if data would be leaked and it would be encrypted, it might not be available in a human readable format. So even if the data is leaked and encryption is strong enough, it would be not possible like to have data in a human readable format. So that way we can still be saved technically. And like to check like how do we verify like medical data that that is taken from Kaggle is correct or not. So it again depends on the data standards that are being followed and the procedures being followed while doing while pre-processing is happening in terms of medical data. Yeah, uh, that's all. Any other question?
No, sir.
Okay. Yeah. So
Uh,
sharing up an example wherein how it would be beneficial to the patient. So let's take an example wherein when somebody is having um, um, health reports being taken at a regular interval, and the data that is being gathered is being pre-processed, and um, by that way they can have a preventive care as well. Considering, let's say somebody is having a blood sugar level rising up, let's say with the 40 points in last 10 years. And with that comprehensive data, it would be easily predictable, like um, 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 is it possible or in a near future, like for a patient to develop a diabetic condition. So this way it would be helpful, like for predicting the actual medical conditions. Okay. Last slide we have is like about the drawback for the patient. Again, it possesses the privacy and security risks. It has data fragment and inaccuracy if records are having outdated information or inappropriate treatments. Digital divide, basically patients currently lacking digital literacy in terms of accessibility to the healthcare systems, electronic healthcare systems. Again, a consent and control concerns that patient might not feel easy, like how the data is being stored or shared. And the information overload, basically complex data that may confuse the patients rather than empowermenting them. So yeah, this is the summary that we just briefed about the benefits and drawbacks for this. And lastly, we have like future trends, how it would happen. We would have cloud-based solutions, hybrid models, wherein healthcare organizations, opting cloud platforms for scalability and flexible data storage and sharing. Hybrid models combine private and public clouds, optimizing security and cost efficiency. Same thing goes with the artificial intelligence and machine learning that will revolutionize the data analytics and automating the data aggregation, pattern recognition, and predictive modeling, which we just shared an example. Same thing, interoperability and real-time data exchange would be more advanced, and standards like FHIR and APIs will enable real-time and secure patient data across diverse health systems and close coordination, basically reducing the duplicate testing or errors. Data security innovations, it would help cybersecurity to get enhanced, like including blockchain adoption, data protect and privacy. Patient-centered data management, empowering patients to control over their health data through mobile apps, portals, wearable integrations. Big data and population health analytics. Basically, it helps to healthcare data to diverse data from the diverse sources that will again fuel up the analytics. Regulatory compliance, stricter data protection laws globally will and mandate enhanced protocols for privacy and consents. So, all in all, possibilities includes faster and efficient clinical trials, AI-driven clinical decision support systems, seamless coordination across care providers, payers, public health agencies, adequate access to personalized medical, particularly via telehealth or wearable technologies, enhance patients' engagement and ownership of the health information. Yeah, um, that's pretty much it from my end. Anybody has any question?
Any questions?
Yeah, hello, sir.
Yeah.
This is Dr. Raghav. Actually, I'm just asking that I just want to do some work in the field of healthcare related to the yoga.
Okay.
I'm doing some work. So, some biofield measurements data available online or not? I just want to inquire that.
Currently, I'm not sure in terms of yoga. Um, there is data available for sure for preventive healthcare, wherein if somebody is developing any condition, medical condition, and how it would, being utilized in terms of predictive care. But I'm not sure if we have such data available for yoga. I'll still get my hands on by searching out for sure. I just
Yeah.
request you to post down that question in the chat box so I can
Right.
have it later as well.
Another thing, sir, is there any low-cost wearable sensor platform for IoT or IOBNT suitable for academic research on the yoga-based health studies?
Low cost effective, I would say no. Currently, no. Even a very last example, like in a Apple Watch, we have like blood monitoring, blood sugar monitoring available using
Yes.
Apple Watch, but it is still costing us a hell lot of money. And apart from that, it is providing currently a subscription based model. So every month we'll have to pay. So low cost, I am not sure we have it as of now, but in future we might have.
So any open source tools or libraries for integrating multi-sensor data like pose detection or biometrics for machine learning applications?
No, not I can think of. But one platform that I have, which is basically less expensive than Apple. There is a Fitbit. If you might have heard,
Yeah,
there is
Fitbit I have
a,
heard.
yeah. So basically, it provides way more data at competitive rates. Basically, it gives at least 5 or 6 type of data, like SpO2, oxygen monitoring, blood pressure monitoring,
So is there any
sleeping
data
patterns.
set available, Indian based or anything related to that so that we can have further research about that? Actually, I want to
Uh,
look at the effect of pranayam on things like that.
no, nothing I can think as of now. But I'll surely take a look and will search out if I can find anything. Just requesting you
Great.
to post your question in chat box.
Sure, sure, sure.
All right.
Okay. Thank you.
Yeah. All right.
Okay.
Yeah. Thanks a lot for
Okay.
um, everything. Yeah.
Okay. Thank you, sir. Thank you very much for your valuable time and for this informative session. Thank you, sir.
Welcome. Bye.
Bye. All the participants within just our next